everyone, and welcome to week 4 of the Data Engineering Zoom Camp. This week, we're going to be talking about analytics engineering. And to get us started, what is analytics engineering? In order to answer this question, we need to look back a few years to the latest developments in the data domain. We've seen how cloud data warehouses like BigQuery, Snowflake, or Redshift, they lower the cost of storage and computing. How tools like Fivetran or Stitch simplify the ETL process. How SQL first tools like Looker that also introduce version control systems to the data workflow. And that along with other BI tools like Mode, they enable self-service analytics. And lastly, data governance. They changed the way the data teams were working, but also the way the stakeholders were consuming that data. And this left a gap in the roles that we had in the data team. So if we think about a traditional data team, we're going to recognize here the data engineer, the data analyst, and here we can also mention the data scientist. The data engineer is going to be preparing and maintaining the infrastructure that the data team will need, where the data analyst is going to be using the data, hosting it in that infrastructure to answer questions and solve the problems. With the latest developments that I mentioned before, we've seen how nowadays data scientists and analysts are writing more and more code. But they are not meant to be software engineers. They haven't been trained for that, and this is also not going to be the first priority. And we see something similar with the data engineers. They are great software engineers, but they don't have the training in how the data is actually going to be used by the business users. And this is the gap that the analytics engineer is trying to fill. We're going to be talking about a role that has a little bit of both of this, data engineer and data analyst, because it's going to introduce the good software engineering practices from the data engineers to the efforts of the data analyst and the data scientist. And here is a little bit of the tools that the analytics engineer may be exposed to. It can be data loading tools like Fivetran or Stitch, or it could also be here the part of the data engineer like you've seen in week 2. The same goes with data storing. They could be managing tools like cloud data warehouses, or this could also be some of the tasks shared with data engineers, as you've seen in week 3. They're going to be taking care of the data modeling good practices with tools like dbt or Dataform. And lastly, the data presentation with BI tools like Google Data Studio. And these last 2 parts are the ones that we're going to be focusing on this week. Let's now review some of the data modeling concepts that we will be referring to. Let's recap on the difference between ETL and ELT. In ETL, we're going to be extracting the sources, then transform it and load it to the data warehouse. Where in ELT, we're going to transform the data once it is in the data warehouse. The first approach, it's going to take longer to implement because we first have to transform that data. But this is going to also mean that we're going to have more stable and compliant data because it's clean. Where on the other hand, the ELT, it's going to be faster and more flexible because we already have that data loaded here. This is also taking advantage of the cloud data warehousing that lower the cost of storage and compute. We now don't have that restriction, so we can afford loading all of our data and then transform it in the same data warehouse. We are now going to dive more and more in this transformation step. Let's review some of the concepts around Kimball's dimensional modeling. The objective here is to deliver data that is understandable to the business user, but also trying to deliver fast query performance. And like the third normal form, here with Kimball's dimensional modeling, we're not going to be prioritizing the fact that data must only appear once. So we are not going to take care that much on making sure that the data is not redundant. We're going to prioritize user understandability of this data and also query performance. Other approaches that could be interesting if you want to dive in more in this topic could be Bill Inman and Data Vault. Let's see the elements of dimensional modeling. We're going to be talking mainly about two types of tables: fact tables and dimensional tables. This is also known as the STAR schema. Fact tables are going to be measurements, metrics, or just facts about our business. They correspond to a business process, and we can think about them a little bit more about like verbs. So we're going to be talking about sales or orders. Where the dimensions, they're going to provide context to these fact tables. They're going to correspond to a business identity, and we can think about them a little bit like nouns. So like customer, for example, or product. Another nice analogy that is presented in Kimball's dimensional modeling is the kitchen analogy. And the book compares how the data warehouse in the ETL process could be compared with a restaurant. We're going to have in a stage area where we're going to have the raw data. This is not meant to be exposed to everyone. This is only meant to be exposed to the people that will know how to use that raw data, in the case of the restaurant, the food, in order to process it and make food out of it. We then are going to also identify the processing area. This would be the kitchen in a restaurant. Here, we're going to take that raw data and we're going to make data models out of it. This is limited, again, to only people that know how to do that, the cookers. And here they'll be focusing on efficiency and making sure that there are standards being followed. And lastly, we have the presentation area, which is the dining hall. And it's the final presentation of that data. This is where we have the exposure to the business stakeholders. We're going to see how in our project, we're going to be doing these exact steps as well with our data transformation.